Welcome back to the channel, everyone. Mr. Honig here. Today we're going to talk about equivalent expressions and how to actually simplify these expressions. So a lot of times we're going to get a bunch of stuff, a bunch of variables. We have our coefficients. Sometimes they'll have exponents in there. A lot of times we'll be given this direction, which is said to simplify. Okay? And what simplification actually means is to take all of this and rewrite it in a simpler form, okay? So when we're talking about equivalent expressions, we want to know what would also be equivalent to all of this up here, okay? So general rule of thumb is we're going to be doing one of three things, sometimes multiple. We are either A, going to combine like terms. Second, we are probably going to use some distributive property. And then third, we may be asked to factor, okay? So this is kind of where we're gonna push off and make sure that we can look at this and say, all right, I know I have to do several steps in order to write an equivalent expression, okay? So what I see first here, a lot of times when we see these terms in parentheses, a lot of times we should be thinking, I have distributive property here, which we do, okay? So the factor we are distributing to the first set would be 5, and make that 5 times negative 3n, and then 5 times negative 8. Okay? 5 times negative 3n is negative 15n. 5 times negative 8 is negative 40. Okay? Now, in this second set, I have to be careful because I have another distributive property problem right here. Okay? And I'm distributing this negative 7 to both 4n and negative 12. Again, notice how I talk about these as terms of positives or negatives. So negative 7 times positive 4n becomes negative 28n. And then we have a negative 7 times a negative 12 ends up becoming a positive 84. So if this was a multiple choice test, this right here is technically an equivalent expression to what our original was. So sometimes if they're a multiple choice test, they may actually give you this and say, is this equivalent? And you would check that off and say, yes, it is. Okay? So then I go to my next set. And now I've taken care of my distributive property. Right now, I'm going to start looking for combining like terms. So in this case, what do I have that are like terms? Well, I'm going to box those off. I have my variables, this negative 15n, and this negative 28n. Notice how I take the sign with it. So now what I'm going to do is I'm going to combine those coefficients. I'm literally just going to say, all right, I have negative 28 and negative 15. Add those together. We get negative 43 for our coefficient, and our variable n stays the same. The same is true when I start looking at my integers. Negative 40, positive 84. Different signs in that case. I'm going to subtract 84 minus 40, which ends up being a positive 44. And this right here is your simplified version, but it's also an equivalent expression to your original. So technically here we have two sets of equivalent expressions. And as well, we had to first distribute and then combine like terms, which will typically be the way we work. Now, that being the case, what happens if you're given something like this? All right, so we said those three things we're looking for. We're looking for either combine like terms, we're looking to distribute, or the last one is we could look to factor. Okay, well, there's nothing to distribute here. I don't see parentheses, so that one's out of the mix. And if I try to combine like terms, I have a y value here, but I don't have a y value here, so that is out of the mix as well. So my only other option is to factor. And remember, with factoring, this is all about division. Okay? So I gave you decimals here, which isn't the end of the world. Okay? And I also gave you a lead term with this negative 1.5. So what I'm going to do is I'm going to divide these by that lead coefficient, that negative 1.5. And why I know it's negative 1.5 here is because I have an equal 0.5 in the back here. I know I can take out 1.5 from both. So I'm going to divide both of these by negative 1.5. That 1.5, remember, we're going to take that and pull it out of our distributive property problem. We are just doing reverse distributive property here. Ends up becoming negative 1.5, okay, times the quantity, Negative 1.5 divided by negative 1.5 ends up becoming 1, so you're left with 1y. I have a positive divided by a negative, which is a negative. And then 13.5 divided by 1.5 ends up becoming 9. So this right here, negative 1.5 times the quantity, y minus 9, ends up being your equivalent expression for that as well. So two different examples, one with both combining like terms and distributive property, the second one with factoring. You're going to have to determine which one to use when you move forward.